In the quiet hum of a small town, a new kind of light flickers. Soft, steady, eternal. It's not sunlight or coal smoke or the restless whir of a turbine. It's something smaller, denser, older than life itself. A miniature sun, sealed within steel, humming beneath the earth. This is the dawn of a new energy age. The mini-nuclear reactor. For generations, the word nuclear meant danger, mushroom clouds, radiation, disaster. It was a symbol of what happens when human ambition outruns human wisdom. But now, that same word carries a different promise. The chance to harness the raw power of the universe, safely, cleanly, quietly. Imagine a world where power plants are the size of shipping containers, tucked away behind schools, hospitals, and neighborhoods, running silently for decades without a single puff of carbon. A world where energy never sleeps, never pollutes, never fades. It sounds like science fiction, but it's not. It's real, it's happening, and it might just rewrite our entire relationship with power. At the heart of this idea is something almost poetic. The same fire that fuels the stars, now tamed by human hands. But unlike the cosmic fusion that lights the sun, these reactors rely on fission, the precise splitting of atoms to release unimaginable energy. Traditional nuclear plants are massive billion-dollar fortresses of concrete and steel, designed for scale but burdened by fear and bureaucracy. Mini-reactors, or small modular reactors, SMRs, flip that model upside down. They're compact, factory-built, designed for transport and rapid deployment. They can be buried underground or stationed in remote regions, bringing light to places where the grid never reached. But beyond the technology, there's something deeper, a quiet rebellion against fear itself. Because the greatest obstacle to nuclear power has never been physics. It's psychology. Fear of meltdown. Fear of radiation. Fear of repeating history. But this time, the engineers whisper, this time the story ends differently. To understand why, we have to peer into the heart of the atom, a world so small, yet so powerful it bends imagination. Inside uranium-235, protons and neutrons are bound together by forces so strong. Splitting them releases bursts of heat and light that dwarf chemical reactions. When we split atoms, a fraction of their mass converts directly into energy. Einstein's E equals mc, brought to life. 1 gram of uranium can release the same energy as 3 tons of coal. That's not metaphor, that's physics. Traditional reactors required complex cooling systems and human oversight to control this immense force. But new mini-reactors use molten salt, liquid metal, or gas self-regulating, passive coolants that don't depend on pumps or power grids. If the reactor overheats, it naturally slows itself down. No meltdowns, no explosions. Just silence. It is as if the machine itself understands restraint, a kind of mechanical wisdom built from decades of learning what not to do. That is what makes this new generation of reactors feel almost alive, not in the biological sense, but in their harmony with nature's own laws. Instead of fighting physics, they surrender to it. These reactors are sealed, self-contained, often buried underground. They need no external water source, no fuel delivery every few weeks. Many are designed to run for 20, even 30 years without refueling. They're not massive grids that feed millions. They're local hearts of energy, beating quietly beneath the surface. Each one serving a small community, a hospital, a data center, or a remote Arctic village. It's decentralization at its purest form, independence wrapped in steel. A new philosophy of energy, smaller, safer, smarter. The engineers call it walk-away safety. If every human disappeared tomorrow, the reactor would simply cool itself, settle into silence, and wait. No alarms, no catastrophe, just a hum, fading gently into stillness. In Alaska, that philosophy is becoming reality. A company named Oklo is building one of the world's first commercial microreactors, the Aurora. Forget the towering chimneys and water vapor clouds of old. This one looks more like a sculpture than a reactor, sleek, compact, elegant. It generates about 1.5 megawatts of power, enough for a small town. No moving parts, no refueling for 20 years, no emissions, just a continuous stream of heat and electricity from a machine that fits inside a shipping container. Oklo's dream isn't to build power plants, it's to build trust. To show that nuclear energy doesn't have to be a monster in the basement, that it can be beautiful, even graceful, because behind every watt of energy, there is something sacred. The promise that we can finally wield nature's most dangerous tool without burning ourselves again. The Aurora reactor is more than technology, It's redemption, forged in uranium and humility. But we can't talk about nuclear energy without confronting its ghosts. Chernobyl, Fukushima, 3 Mile Island, names that still sting decades later. Images of explosions, evacuations, invisible poison drifting through the wind. Those memories became a warning that never fades. But the truth is, modern reactors are not their ancestors. The systems that failed in 1986 and 2011 were designed with fragile human-dependent controls and outdated assumptions. Mini reactors don't share those flaws. Their small size means less heat, less pressure, and far fewer points of failure. They don't rely on water cooling or massive containment domes. They use physics itself as protection. If something goes wrong, the reaction stops, because that's how they're designed. Not to fight chaos, but to end it naturally. This is the quiet evolution of nuclear science, an energy source that learns from its scars. The possibilities are staggering. Imagine entire regions powered without fossil fuels. No coal trains, no gas pipelines, no smog curling into the morning sky. Factories, cities, even nations running on silent reactors that hum day and night, immune to weather or fuel shortages. And because these reactors are modular, they can be mass-produced, shipped, and installed like any other industrial product. That changes everything. No more billion-dollar construction nightmares. No more politics of scale. Just plug-and-play power. For developing countries, this means sovereignty. No more dependency on imported fuels or unstable grids. For the world, it means hope. A genuine, measurable chance to slash carbon emissions without sacrificing reliability. Solar and wind give us light when the sun shines and the air moves, but nuclear gives us constancy, the steady heartbeat of progress. In that steadiness, there's comfort, and maybe even peace. Yet there's a beautiful irony in all of this. For centuries, humanity has feared the atom, the smallest thing, for its potential to destroy everything. But now, it's that same atom that might save us. The same process that forged stars could now light our homes, and the same force that leveled cities might now heal a planet. There's poetry in that symmetry, in the idea that the destroyer becomes the redeemer. Mini reactors could even power space colonies, lunar outposts, or deep-sea research bases. NASA has already begun testing compact nuclear systems for the Moon and Mars, because solar power fades where sunlight is scarce. Out there, in the cold silence between worlds, nuclear energy becomes humanity's eternal flame. Our portable star, if we dream of becoming a multi-planet species, will carry this technology with us, not as a weapon, but as a heartbeat. Of course, every revolution meets resistance. Environmentalists raise valid concerns. What about nuclear waste? What about security? What about trust? Politicians hesitate, haunted by old headlines and public fear. But the truth is, the waste from a mini reactor is shockingly small, about the size of a suitcase, after decades of operation. It's solid, sealed, and easily contained, unlike the billions of tons of invisible carbon we dump into the sky each year. And while coal kills millions through pollution, nuclear power has taken far fewer lives in its entire history. The math is undeniable. The problem isn't radiation, it's reputation. We told the wrong story for too long. We made the atom a villain, but maybe it was never the villain. Maybe it was the misunderstood genius we weren't ready to listen to, until now. And so we pivot, we go smaller, we go smarter. Bill Gates' company, TerraPower, is building advanced reactors cooled by molten salt, stable, elegant, efficient. Rolls-Royce is designing small modular reactors for the UK grid, compact enough to fit within a stadium. Across the world, dozens of startups, from Copenhagen to Seoul, are racing to bring microreactors to life. They all share one vision: clean, compact, continuous energy. Power that doesn't care if it's night or day, summer or storm. Power that never sleeps. In an era obsessed with growth and noise, maybe the answer was humility all along. A quieter kind of progress. Because the future doesn't need to, it just needs to hum. When you step back, this story becomes more than engineering. It's a mirror. It reflects something ancient and human. Our endless dance between fear and curiosity. We are the species that split the atom and then feared our own brilliance. But progress is not about fear. It's about forgiveness. To trust nuclear energy again is to trust ourselves again. To believe that we can hold fire without burning. This technology is not just energy, it's a moral test. Can we use it wisely? Can we resist the old urge to dominate and instead learn to collaborate with nature's laws? Because in the end, splitting atoms is easy. What's hard is learning restraint. The power of a star means nothing if we can't control the darkness it casts. Still, for this dream to live, the story must change, not the science. Science already solved the problem. What remains is trust. Trust between governments, between companies and citizens, between generations. If we can build reactors that children can walk past without fear, that communities can rely on without question, then nuclear energy can finally step out of the shadows. Maybe the true revolution isn't technological, it's emotional. Because in every new invention lies the echo of old mistakes. Forgiveness becomes innovation's quiet twin, and maybe that's the final lesson the atom has to teach us. That power, in its purest form, demands humility. Picture this, it's 2040. Your town runs on a reactor no bigger than a truck. No fuel shipments, no smoke, no noise. The air feels cleaner, the nights brighter. Hospitals, schools, and homes, all powered by a single core of uranium, glowing softly beneath the earth. The stars above shimmer and below. A fragment of their fire keeps your world alive. The hum of that reactor is like a heartbeat, constant and reassuring. Children grow up without ever knowing blackouts. Farmers irrigate fields without counting diesel costs. The local cafe brews coffee with the warmth of a star. In that quiet continuity, you realize this is what progress should feel like. Not chaos, not conflict. Just calm, radiant continuity. Humanity, at last, has learned not to fight the flame, but to hold it gently, and that's the poetry of it. We've always been creatures of fire. From the first spark struck in a cave to the hydrogen bomb, fire defined us. It burned our cities, but it also lit our way. The mini-reactor is simply the next chapter. Not a new kind of danger, but a new kind of discipline. The ability to control immense power without being consumed by it. In the hum of a reactor lies the hum of wisdom, soft, patient, enduring, because the future isn't just about bigger machines or faster growth. It's about the courage to choose balance, to choose silence over spectacle, to choose light over fear. And maybe, just maybe, that's what it means to evolve, to glow, not to explode. So when you hear the word nuclear, take a breath. Don't think of disaster. Think of light. Think of the sun, not in the sky, but in your backyard. Think of energy that never sleeps, never pollutes, never ends. The future of power may not be vast fields of wind, turbines, or solar panels stretching to the horizon. It may be smaller, hidden, humble, perfect. A light beneath your feet. A quiet machine that whispers the same promise the stars have whispered for billions of years. That energy can be infinite, if we learn to handle it with grace. Because the power of a star has always been within reach. The only question was whether we were wise enough to hold it. And now at last, we are. Humanity, standing not in fear, but in awe. The power of a star, reborn in human hands.